Hey everyone, Chang here and welcome to my channel. Today we're going to focus on counting. Yes, another counting video. Okay, I spent a great deal of time on counting, right? We had our basic counting, then we had our permutation, then we have our combination. And no, today we're not going to focus on another different way of counting. Today it's more of a strategy, a sort of supplement to those counting, I guess, videos, right? Now, usually in terms of counting problems, they're not going to be super explicit on whether it's a combination or a permutation problem. But you can tell based on the context of the problem whether order actually matters or not. So let's look at this problem really quickly. You flip a coin 6 times. How many ways can you flip it so that you have at least 2 tails? Now, since it's talking about how many ways you can flip it so that you have at least 2 tails, you see that the context itself, order itself doesn't matter. It doesn't matter that maybe the first time you flip the coin is a tail and then the last one ends up being a tail, or if it's the first and the third, so on and so forth. So order doesn't matter. In this case, order doesn't matter means that it is combination, right? So we can solve it using combination and the formula for combination. But today we're going to focus on what I want to say is called negative counting or complementary counting. I don't know what to call it actually. But basically the strategy is quite simple. Rather than counting what they're asking, we're going to count the opposite. And the reason for that is not that it is necessarily more correct or anyway, but it's just that, like I said, it's a strategy. And sometimes just counting the opposite just makes our lives so much easier. Because this problem is going to be slightly tedious if we go about it the conventional way. But if we use complementary counting, it actually will go a lot quicker. So let's just solve it the conventional way first. Well, when you look at this, and we've read the problem, we know that we're flipping a coin 6 times. We're looking for at least 2 tails as the end result. We got to figure out what possible scenario would end up with at least 2 tails. Well, in this case, there's actually several. We have 2 tails, right? You flip it and you have exactly 2 tails. Great. But since it's at least, we also have to worry about the situation with 3 tails, and the situation with 4 tails, and the situation with 5 tails, and the situation with 6 tails. Oh man. Okay, cool. Now, to save ourselves some time, using our skills and our understanding of combinations, all those are going to be in the link in the description down below. So combination, there's a formula, right? In this case, fairly simple. 6 factorial over 2 factorial, 4 factorial. Just like that. And of course, if you wanted to reason it out or just basically simplify this, it's going to be 6 times 5 over 2. And we can go on. This is 6 factorial, 3 factorial, 3 factorial. Basically 6 times 5 times 4 over 6. This is going to be 6 factorial, 4 factorial, 2 factorial, which is 6 times 5 over 2. Once again, these are basically the same thing, right? Just flipped a little, but the multiplication. So they're the same. All right, here we're going to have 6 factorial, 5 factorial, 1 factorial, which is basically 6. And then we have 6 factorial over 6 factorial, or as some people would like, and 0 factorial, which is just 1 right here. So that's just going to be 1. All right, so this one we can solve. 30 divided by 2, 15. Right? 6 cancels 5 times 4, 20. Once again, 15. 6 right here, and 1. Add them all together, and we can do that. 15 plus 15, 30, plus 20, 50, plus 6 plus 7. Final answer, 57. That wasn't bad. A little tedious because we had to look at all these different scenarios, but wasn't bad at all. Now, let's look at this problem again, except for we're going to use complementary counting. We're going to look and count the opposite. All right, so rather than trying to figure out situations with at least 2 tails, we're going to look at a situation that doesn't have 2 tails. Well, there's only 2 of them, right? We have our 0 tail that doesn't have at least 2 tails, and we have our 1 tail that doesn't have at least 2 tails either. So 0 tail, only one way, right? Because guess what? They all have to be heads. If any one of them ends up being basically tails, then you can't really fall into the situation. Simple as that. 1 tail. If you want to use the formula, that's simple. 6 factorial 1 factorial, 5 factorial, which is basically 6. Or if you wanted to reason out, it is still 6. If you think about the coin flip, right? There it is. 6 coin flip. Well, if this is tail, all of these have to be head. That's one possibility. If this is tail, all these have to be head. That's 2 possibility. And you go on and until you reach the end. 6, right? Simple as that. Well, okay, what can we do? 1 plus 6 is actually 7. That's not bad. But that doesn't give us the answer because from the previous, we already know the answer is 57. Well, what we can do in this situation is, well, find all the possibility, right, of flipping 6 coins. That's simple. Each and every one of them either has a heads or a tail. So technically, there's 2 possibility, 2 possibility, 2 possibility, 2 possibility, 2 possibility, and 2 possibility. Technically, 2 to the 6th power. And then we're going to subtract this guy, the one that we don't want. Simple as that, right? So 2 to the 6th power. Very quickly, guys, 64. 64 subtract 7 is 57. And just like that, we once again have our answer. Now, this one saved us a good deal of time. Maybe not as much as we might have hoped if we were doing very quick math in the previous, like, I guess you could say, example or way of solving it. But still, this saves us a lot of work, I guess you could say. So, this is complementary counting. Now, it doesn't mean, oh, I just found this and I'm done. We still have to answer the question. But the idea is that rather than trying to figure out all the possible scenario, sometimes the scenario that we don't want is a lot less. So we would count those and then just find the total possibility, total different ways, and then subtract all the ones we don't want. So here's one. Let's look at another problem. All right, so with this problem, I'm hoping that complementary counting or negative counting is a lot simpler than trying to go about it the regular way. Now, the reason for that is because when we look at the problem, we'll see. How many 2 digits whole number uses 2 different digits? Well, what does that mean? Here's 10. That's a 2-digit number, right? That uses 2 different digits, 1 and 0. And we can keep on going. 12, 13, 14, 15, blah, 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 blah. And if you really want to, you can go and keep on counting until you figure this out, and you definitely will, and you definitely can. I will stand here and listen to the dog bark, and hopefully by the time you're done counting, right, I will be able to grow a lovely mustache and a long beard and look a lot wiser. No, probably not. But realize that it's actually going to take a great deal of time to figure out, does it fall into this category, does it not, and it's just going to drive you bonkers. So, what we're going to do is we're going to count the opposites. That's going to save us a lot of time. First and foremost, let's just figure out how many total possibilities for 2-digit whole numbers, ignoring the 2 different digits, just how many possibility of the 2-digit whole numbers. And that's going to be 90, right? And you guys can verify for yourself, plain and simple. All right, now, we want to get rid of all the stuff that we don't want. Well, since this problem is technically asking for 2 digits that are different from each other, let's just look at all the 2 digits that are the same. 11, 22, 33, 44, 55, 66, 77, 88, 99. Just like that. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you really didn't need to count to 9. You realize that's just 9. So total, I guess you could say possible 2-digit numbers minus all the ones we don't want, which is going to be minus 9 based on these guys. And just like that, boom. That is our answer. Plain and simple. And of course you guys can count if you want, but why would you do that when this can save you so much more time? All right, let's look at this next one. How many whole numbers less than or equal to 40 are not divisible by 4 or 5? Of course you can count them, and testing whether it can be divisible by 4 or 5, not that great. So what we're going to do, complementary counting. Plain and simple. How many whole numbers are there? 40 of them. Great. Simple as that, right? And just to let you know, whole numbers in this case is that mathematical whole numbers, everything from 1 all the way to 40. 0 does not count, and negative number does not count, okay? So that's just by mathematical definition of whole numbers. So 40. There it is. Now, we want to find all the ones that are not divisible by 4 or 5. Well, in this case, we're going to count the opposite. We're going to look for all the ones that are divisible by 4 or 5. Well, if we're looking at just the 4, let's just put it right here so that it's obvious that we're just looking at all the different possible numbers that are divisible by 4. Those are all the possible numbers, right? I guess you could say less than or equal to 40 that are divisible by 4. Well, let's look at 5. We're almost done. That's all it takes, right? The one caveat is, for a problem like this, you got to be careful because certain numbers actually repeat itself, so we don't want to overcount them. So, for example, 20 and 20 here, we probably shouldn't count them, right? 40 and 40 here, we probably shouldn't count them twice at least, right? Other than that, we're good to go. So, how many is that? Well, if we're going to count, like, we just don't want to overcount, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And just like that, we realize there's 16 numbers that we really don't want to count. So we're going to minus 16. And then just like that, we figured out the answer, right? Which is going to be 24. Plain and simple. Once again, you could definitely go and count and check and see if each and every one of them are not divisible by 4 or 5, or just do the opposite. And the opposite will save us so much more time. All right, so we reached the end of this video. Now, once again, this is not something completely new. I want it to be more of a supplement. Each and every one of the problems that I presented and each and every one of those counting problems, usually and most of the time, if not all the time, you can solve it with the combination and permutation formula, right? And as long as you can break it down, don't get confused, isolate each and every one of the possible scenario and count them, you're good to go. This video is just a supplement. It's a strategy, right? Certain problems, depending on the context, can be achieved a lot quicker if you do the opposite. So hopefully with this, I've illustrated and highlighted the potential of counting the opposite. Not all of the problem you can do this. There are some, use your best judgment, try to read it through, and worst case scenario, if you're not sure, just go about it the regular way, the conventional way. As long as you're organized, right? You don't overcount, undercount, all that other stuff that I've introduced in the other videos, then you're going to be fine. Thank you for watching this video. See you in the next one.